So far, you learned about logical connectives and how they help creating compound statements. The logical connectives are conjunction, disjunction, negation, implication, and biconditional. You can watch my previous videos for more information about connectives. Compound statements have their own truth values that depends on the simple statements they are made of. Individual statements are true or false and evaluated to a single truth value, which is the truth value of compound statement. You can see all outputs of a compound statement in a truth table. The number of rows in a truth table depends on the number of variables in compound statement. When all the outputs of a compound statement is true, it is called tautology. So a tautology is true for any input combination of truth value of individual statements that are part of the compound statement. Let P be the statement you are happy and negation of P is you are not happy. The compound statement you are happy or you are not happy is a tautology. It is always going to be true. If we draw a truth table for this statement, we can see that the output is always true for any value of P. The tautology is used to establish logical equivalence, about which you will learn in the next video. So what happens when we negate the previous compound statement? Negation of P or not P is obtained by negating every variable and the logical connective in the statement. Not P and P is a new statement called contradiction. The truth table for contradiction has the same number of variables and rows. The output of not P and P is false for all inputs. The statement not P and P is the compound statement you are not happy and you are happy. So you can't be happy and unhappy at the same time. This is a wrong statement. Let us see a few examples of tautology and contradictions. P implies Q or Q implies P. There are two variables in this compound statement, so there are going to be 4 rows and columns for P, Q, P implies Q, Q implies P, and P implies Q or Q implies P. Let's draw the truth table and enter the truth values for P and Q as usual. Enter values for P implies Q, where only entry that is false is when P is true and Q is false. Similarly, enter truth values for Q implies P. Finally, evaluate the original compound statement P implies Q or Q implies P. It is a tautology because all entries are true. Find if the given compound statement is a tautology or contradiction. P implies P or Q. There are two variables, that means we have 4 rows in the truth table. The column are P, Q, P or Q, and P implies P or Q. Enter truth values for each column and evaluate the final output. The result shows that this compound statement is a tautology where all entries are true. The contingency is all other statements that are neither tautology nor contradiction. They have both true and false values in the output for input combinations. Let us take a look at the truth table of statement P or P and Q. The truth table contains values that are false as well as true. This is contingency.